Hey there, it's great. Today we're talking about something completely new, and it's something I absolutely love because it takes a little bit of understanding and logic, but I think once the explanation sinks in, it'll make perfect sense. But you're gonna have to pay close attention. Like I said, completely new and a little bit awkward, a little bit weird to look at first. They're called absolute value equations. So we're familiar with absolute value, we're familiar with equations, but something funky kind of happens when we put them together. So let's check it out. The notes you need to take to start is that, just a reminder, the absolute value turns the value inside positive. So whatever value is inside the absolute value, remember it can't affect a negative on the outside. You can't play add ops over the absolute value. But whatever value is on the inside, it's going to turn it into a positive value. Second note is that absolute value equations typically have two solutions or no solutions. And I'm going to give you an example of each. I say typically because there is a specific case when an absolute value can have one solution. Absolute value equation can have one solution. But I'm going to leave that as a critical thinking question for you guys, maybe on a test or a bell work, or just to think about after you get a little taste of it with the rest of this video. Third note is a kind of a step or a guide to solving absolute value equations. And the idea is to find the solutions to an absolute value equation. You have to isolate the absolute value. So get this grouping symbol by itself on one side of the equation, and then set whatever's on the inside equal to a positive or a negative. So the idea here is that if we have it already isolated, like x is equal to, I love the number 37, it's a great prime. If we have x is equal to 37, well, we're going to say that there's two ways that we could put in a variable for x and get the answer 37. So if x is 37, well, then the absolute value of 37 is 37. But x could also be equal to negative 37, and this would still be true, because if we put a negative 37 on the inside, well, the absolute value is going to turn it into positive 37, and we're going to be all good. It'll still be true. So that's why an example of how we can have two different solutions to this, and that's going to kind of help guide our process for solving. Let's look at some examples. The first one I'm looking at is the absolute value of 3x equals 24. So what I'm thinking to myself here is there are two ways that I can take the absolute value of 3x and get 24. And the two different ways are, well, if 3x is equal to 24, then I'll be good. If we have 24 on the inside, then the absolute value of 24 is 24. But also, if 3x, when multiplied, 3 times whatever x is equal to negative 24, then when we take the absolute value, it's going to turn into 24. This will also be true. So what we're going to do is just solve these two separately and say I'll divide both these by 3. And x could equal 8. Or I could divide both these by 3. And what value of x is going to give me a negative 24 on the inside? If x is equal to negative 8. Now it's important to point out that it's not always just the positive and negative version of a single whole number, or two integers that are just opposites. Instead, it can sometimes vary. We're going to see that in example 3. But in this case, x could be 8 or negative 8. If you plugged in either one, that would be a true statement. So this is the two solutions to this one. Number 2, I'm looking at it and I'm thinking x plus 19, the absolute value of that, the absolute value of x plus 19 is equal to negative 27. And I want you to look at this for a second and tell me, why am I hesitating? And the reason is because we can never take the absolute value of a real number expression and get a negative number. So this is saying take the absolute value of x plus 19 and you'll get negative 27. Well, the absolute value is going to turn any value positive or negative. It's going to turn it into a positive. So it couldn't turn it into negative 27. Even if we found what number added to 19 would give us negative 27 on the inside, the absolute value of that would again be positive 27. So this actually has no real solutions. This has no solutions. Because we can't take the absolute value of something and get a negative number. So that has no solutions. That's why I didn't leave much space, because I kind of planned ahead. And I hope that makes sense to you. So double check, listen again if that you need a little refresher. This third one is more difficult, but the reason I did it as an example was so that you could follow along with me, work through a really tough one, but I also saved you so you don't have to do it for your practice problems. I don't give you ones this difficult. But the idea here is that we're going to follow a MEG and follow that third rule from our notes section, and that was to first isolate the absolute value. So we first want to isolate the absolute value. So we can just follow a MEG in our equation solving steps and say, well, what's going on here? We have x and it's grouped, so this is going to be undone last. So again, either way, we're going to leave that for last. We're going to isolate that absolute value. Then there's multiplication, and there's also addition and subtraction. So we have -3. How am I going to cancel out the -3 on this side? Well, I can cancel out -3 by adding 3 to both sides. If I add 3 to both sides, it'll cancel out on the left. And I have -35 plus 3, a bigger negative, but different signs. This will cancel out to negative. Shoot, let's pretend this was a -2 because that's what I meant it to be. We're going to add 2 to both sides. If we add 2, then we're going to have -33. This is just going to work out better. Just trust me. I'm sorry about that. You could fix it. Luckily, you used pencil. Should look nicer. Now, what's going to fall down is the absolute value of x minus 7 is going to fall down, but also -11. And this is something that a lot of people are going to forget. They're going to forget that the negative sign falls down. And if you're wondering, what isn't it -11 that falls down? Well, if you play add opposites, it's a -11 that just kind of drops down there. So we have -11 times x minus 7. The absolute value of x minus 7 equals -33. I'm going to undo that multiplication by dividing both sides by -11. And we're going to get the absolute value of x minus 7 is equal to 3. Now here's the point where we need to say, okay, now we've isolated the absolute value. There are two different ways we could get +3 as a solution. The two different ways, and this is, I sometimes like to draw it as like splitting this out into the two different solutions. So you could say, well, the x minus 7 is just going to equal 3, and the absolute value of 3 is 3. Or we could say, after we do x minus 7, whatever x may be, we're going to find out, we could get a -3 on the inside, and then the absolute value would turn it positive. So let's solve these two equations to find our two solutions. We'll add 7. In both cases, we're going to add 7. But again, I told you this is going to be a situation in which it's not just the positive and negative version of a single number, or two different numbers, positive and negative opposites. Instead, when we add 7, because this is a -3, -3 plus 7 is actually, figure it out for yourself, +4. So x could be 4 or 10. Again, you can check this by plugging in these two different values in for x and then solving using the order of operations, seeing if you get -35 on both sides, and you will. So x could be 10 or 4. So this is one of those crazy things where absolute value equations just have multiple solutions. It can have two solutions at times. It can also have no solutions. And again, I'm going to leave you some practice problems, and think about, how could an absolute value equation have just one solution? When would that occur? But here are your practice problems. I'm going to read them to you because that absolute value is pretty short, kind of hard to see. This is the absolute value of x minus 9 is equal to 27. That's number 1 for you to do. And number 2 for you to do is 35 plus the absolute value of 7x is equal to 49. So I want you to figure out those two for yourself. Do your best, and I'll catch you later.